Good afternoon, everyone, and thank you for joining us on this World Environment Day 2025 for GoRail's latest webinar, Cleaner, Smarter, Greener, How Freight Rail Helps Companies Cut Emissions. My name is Russ McGurk. I'm the president of GoRail, and I'm very thrilled to welcome a diverse audience today. We've got local leaders from local government, industry colleagues, academics, environmental experts, energy experts, a terrific diverse group. About GoRail, our mission centers on connecting communities to the public benefits of freight rail. And one of the most important of these, and timely, is rail's role in reducing emissions and building a more sustainable supply chain. As businesses across sectors work to identify and implement lower carbon technologies, freight rail is stepping up in a big way, investing in cleaner locomotives, enabling mode shift through intermodal service, and partnering with forward-looking companies like UPS to drive innovation across the broader logistics ecosystem. We have a great group today of presenters. We have, leading us off will be Teresa Romanowski, Associate General Counsel, Association of American Railroads, Mike Swaney, Advanced Energy Innovation with BNSF Railway, Curtis Sloan, AVP of Policy and Sustainability with Watco, William Carnegie, Senior Project Manager, Engine and Fuel Cell with Wabtec Corporation, and Andrew Okuya, Vice President of Public Affairs with UPS. Quick housekeeping item, we'll make sure to reserve time at the end for Q&A, and you can submit your questions using, or at any time, using the Q&A feature up at the top of your toolbar. And please don't worry if you miss anything as we go along, because we're recording today's session and we'll be sharing a replay with all registrants afterwards. With that, thank you all for being here once again, and let's get started with Teresa.
Thanks so much. So I'm going to start by just providing a little bit of background information on railroads and what we're overall doing with respect to technology. Let's see. Is my screen? Can you guys see my screen?
Yes, we can.
Yes.
Okay, great. So just as a little bit of background, railroads come in all different sizes. So we have Class 1, regional, local, and line haul, switching, and terminal. So you can see this is a little bit out of date right now. There are 6 Class 1 railroads in the United States. And then you can see the numbers for regional and local freight railroads as well. This is just to give you an idea of the scope of how much track we have, the number of employees, and the revenue. Again, we have about 140,000 track miles in Canada, Mexico, and the United States. The 6 Class 1 railroads operate over 2/3 of the nation's right-of-way and account for 95% of railroad freight revenue. And you can see this is just a map of the overall U.S. Rail lines coded by owner. So you can see we hit just about every area of the United States. The freight railroads are part of an overall connected network. So we ship around 61 tons of goods per American every year. We move about 1.6 billion tons a year, and carry a whole assortment of different products, from grain to food, cars, motor vehicles, parts, construction-related things, chemicals. So we move just about everything. Turning to decarbonization, each one of the 6 Class 1 railroads and many of the short line railroads have made commitments to near-term emissions reduction targets. They have made public commitments through the science-based target initiatives to reduce their emissions by specified amounts between now and 2050. Our customers are increasingly focused on emissions reductions. So our scope 1 and 2 emissions are scope 3 emissions for our customers. And so they're interested in reducing those for a number of different reasons. As you might guess, diesel fuel usage in locomotives is a primary driver of our emissions. So well-to-wheel emissions associated with locomotive operations accounts for about 95% of the overall rail carbon footprint. We think biodiesel and renewable diesel are going to play a huge role in reducing emissions from locomotive and railroad operations. There are some challenges associated with that. Biodiesel and renewable diesel have a limited supply and limited availability in certain parts of the United States. And the feedstocks that are used to produce biodiesel and renewable diesel are limited. So we compete with other modes of transportation, like the aviation industry, for those feedstocks that allow us to reduce our emissions using biodiesel and renewable diesel. We are, however, using other forms of technology and initiatives to reduce our emissions. So for our locomotive fleet, we're using more efficient locomotives that emit fewer criteria air pollutants in order to help reduce emissions. Rail cars are being designed to be more aerodynamic, and that allows us to move more freight with less gas, with less fuel. We have fuel management systems that network optimization systems that calculate the most fuel efficient routes and speeds for a train to reduce emissions. Again, alternative fuels. And in our yards, we can use truck technologies such as gate systems, gate systems that help get trucks in and out of our yards more quickly so that they reduce idling time. And we also are looking into hybrid and natural gas and battery electric service trucks within our yards to reduce, bless you, Bill, to reduce ambient noise and yard emissions. We also are looking into and starting to implement lower emitting natural gas and battery electric hostlers and diesel switch locomotive filters to reduce emissions within our yards. I'll just quickly go through a couple of the different technologies that we're looking at. I think my friends from the railroads are going to give us a little bit more detail into what they're looking into. But we look at, a couple of different technologies. One is battery electric technology. There are pros and cons associated with that. The pros for a battery electric locomotive is that it reduces emissions, not only carbon emissions, but also criteria pollutant emissions. And they're very quiet, so it reduces noise as well. On the con side, the battery technology it's just not, it doesn't have the capacity to move the trains in the same way that we need them to. So if you look at today's locomotive, it has about a 4,000 or 5,000 gallon diesel tank. You need probably 5 or 6 of the highest end locomotive or batteries to meet that same standard for power. So that we need to improve the technology associated with batteries in order to start using them on line haul service. The charging infrastructure is also a challenge throughout the United States. If you have locomotives that are operating across the country, you need to have charging infrastructure. That doesn't exist today. We also have limited grid capacity in some areas of the United States, making battery electric technology a bit of a challenge. They're also very expensive. Hydrogen is another thing that some of our members are looking into. Oops. I won't go into the properties of hydrogen, but what I will say is it has a lot of potential. There are a few challenges associated with it. For example, on the one side, it's not, depending on where you're getting your hydrogen from, it's not entirely clear that that is a lower emission technology. It's very energy intensive to convert hydrogen into a usable fuel source. So here are a couple of the pros and cons for hydrogen. It's got a low impact on rail operations. We know how to use this type of fuel, but the cost for hydrogen refueling stations are high. And it's got a low volume energy density and would probably still require battery technology for optimal operation. And there are limits to the train range that can be used with hydrogen, again, given the need for fueling infrastructure. Catenary electrification is something that comes up with some regularity. People ask about it. I guess, in other parts of the world, it's a technology that's used. And so it's a demonstrated technology, but it's not feasible in the United States due to the cost. Safety challenges with overhead lines over rail yards is a bit of a problem. Geographic challenges, our rights of way go through tunnels and bridges and regions with limited space on the right of way. The grid instability is something that would come up and have an impact as well. And our freight rail network is not the same as the passenger networks that use catenary in other parts of the world. And so it's just not a feasible alternative. So with that, I'm going to go ahead and hand it off to Mike at BNSF.
Okay, thanks, Teresa. Let me share my screen here. All right, you see my slides?
Yes.
Okay, very good. Well, good afternoon. My name is Mike Swaney. I am the Director of Advanced Energy Innovation at BNSF Railway. For those of you who are unfamiliar with BNSF Railway, Teresa mentioned the 6 Class 1 railroads. We're one of the largest Class 1s. We are headquartered out of Fort Worth, Texas. We are a wholly owned subsidiary of Berkshire Hathaway. You can see some of the stats there. Geographically, we operate primarily in the western 2/3 of the U.S. We move consumer products, agricultural products, industrial and energy resources all around our 32,500 route mile network, which includes a presence in Canada as well as interchange agreements with Mexico, and as well as getting into the East Coast. That happens through interchange with our other Class 1 and short line partners. So I want to talk a little bit about BNSF's commitment to emissions reduction and sustainability. It's a value and a core commitment at BNSF. And these 4 quadrants that you see here are essentially the underpinnings for how we operate and how we work with our customers to reduce emissions. It's worth noting, Teresa pointed this out a little bit. I think I'll take a lot of what Teresa said and just kind of drill down a level to give a little more detail, more color. But rail represents less than 1% of U.S. greenhouse gas emissions. But we're not content to rest on our laurels. We continue to look for ways to further reduce not only carbon emissions, but our criteria pollutant emissions as well, which are really the drivers of local air quality. Today, given my objective to try to be brief and get us to the Q&A session, let the other presenters talk, I'm going to focus primarily on the bottom right quadrant of this equation here. But before I do, quickly, we'll touch on the carbon commitment. Teresa mentioned all the Class 1s have made commitments. BNSF's commitment is a 30% reduction in our carbon emissions by the year 2030, so 30 by 30. And that's off of a 2018 baseline. So you can see the progress we've made. We're tracking ahead of our projected rate that we would need to achieve to hit the 30% target by 2030. On the right-hand side, you can see the primary means of how we plan to meet that target. You can see different fuel efficiency measures, whether that is hardware or software or operating modes for our locomotives. In the purchase of our electricity, we are looking at where we have the opportunity in deregulated markets to purchase as much renewable power as possible. In our locomotives themselves, we are currently testing and evaluating the feasibility of biofuels, both biodiesel and renewable diesel, in our locomotives. And then on the right-hand side there, just to point out a couple other initiatives, we have 4 facilities where we have electric wide-span cranes. And then in the bottom right corner, you see a picture of our Stockton, California facility where we have converted all of our diesel yard tractors to 100% battery electric. In addition, we've got a 750 kilowatt solar array at that facility as well. What I want to focus on, though, is the bottom left. That is the Wabtec Flex Drive. That is a 2.4 megawatt hour battery electric locomotive. You saw a picture of it in Teresa's slides as well. This was a program that we undertook in 2021, funded by the state of California, a technology demonstration grant. The locomotive itself was manufactured by our partner Wabtec. And I put 2.4 megawatt hours here on the slide, not expecting that might mean much to anybody, but just for context, the 5,000 gallons of fuel that we carry on our traditional line haul locomotives today equates to about 200 megawatt hours of available energy. Now, when you think about the inherent inefficiencies of using a diesel engine to produce electricity to power the traction motors or the wheels of our locomotives, you're left with about 75 to 80 megawatt hours of usable energy on a locomotive based on diesel fuel today. But clearly, 2.4 megawatt hours is a far cry from the amount of energy that we're carrying on board today. That doesn't mean that the test didn't mean anything to us. We proved quite a lot. We, as you can see in the stats here, we ran this thing for a little over 3 months in southern central California, traveled nearly 13,000 miles, and we achieved on average a 12% fuel reduction by operating that battery locomotive in the middle of 2 traditional diesel locomotives. So you're left in a situation where you say, well, we have a solution that from a technology standpoint, we've demonstrated that you can produce the equivalent horsepower of a line haul locomotive, but effectively you can only do it for about 3% of the time. Doesn't mean the test was a failure. I would submit that the most significant learnings that we achieved from this test is really developing a framework for how we evaluate new technology on the railroad. We typically say you need 30 to 50 locomotive years of testing to prove out a technology before we release it into production volumes. So clearly we've got a long way to go in continuing to test the technology, but we've developed a sophisticated rationale and framework for evaluating that says, okay, number one, safety underpins everything we do. How do we wrap our arms around something that we have no experience with when it comes to operations and maintenance? Technology suitability. Is this the right technology for the application? Teresa mentioned a few different options there. Operational integration. When you think about things like the fact that today we can fuel a diesel locomotive in less than 30 minutes. How do you contemplate a world where it may take 8 hours to charge a battery locomotive? Do you even have the infrastructure, be it the space or the electrical power, to support charging a locomotive that may need multiple megawatts of power to provide to the locomotive through the charger? How do we leverage our existing fleet of over 5,000 locomotives? If this is going to be a new purchase, there's a natural replacement cycle that we would look at, challenging the OEMs to say, is there a way we can deploy this technology on our existing fleet? And then what is it that is really a near-term option? So we think about it as a pathway to say, look, ultimately long-term, we believe that there is a place for a zero-emission solution that shouldn't stop us from pursuing incremental progress along the way, and things such as certainly biofuels, moving to lithium-ion starter batteries, or using hybrid technology, as we saw in the automotive industry, provides a great template for us to pattern ourselves after. So I think as I wrap up, a couple things I would leave you with. One, just I want to make evident that BNSF is committed to emissions reduction. We value certainly the partnerships of federal and state agencies and our OEM partners, our operating partners. And then lastly, I would say the ability to create a comprehensive and evaluative framework for all of this new technology is going to be critical to helping us achieve our mission of emissions reductions at BNSF and across the industry. Thank you very much.
All right, now we're going to hand it over to Curtis Sloan.
Good afternoon, everyone. I'm Curtis Sloan. I'm VP of Policy and Sustainability at Watco Companies. For those of you who don't know Watco or aren't familiar with us, we're a family-owned, Kansas-based kind of single-source transportation services provider. So what that means is we have 46 short line or regional railroads across the US and Canada. Not on the screen is also a couple in Australia. And then we have a little over 80 terminals and ports that we own or operate around the country, with a couple in Canada and one in Mexico there as well. And we also have a third-party logistics provider division within the company. You know, for the purpose of today, we're focusing, I think, mostly on our railroads. If you're not familiar with the term short-line railroad, we go back to kind of Teresa's chart at the beginning. You know, there are 6 large Class 1 railroads that are kind of the household names that many people think of. For our railroads at Watco, you know, a short line can be quite short, you know, it can be a couple miles or it can be quite long. But when we talk about short lines, we're really talking about kind of the first mile, last mile feeder network into those larger Class 1 railroads. So that's just a glimpse of our network map. You know, we're pretty heavy kind of in the Midwest and the South, but we are in over 30 states around the US. Every PowerPoint we do at Watco, we talk about 3 foundation principles because they guide everything we do at the company. 1, value our customers. That probably doesn't need to be explained at all. We value our customers. Without them, we can't stay in business, right? And we can't then take good care of our team members, which is our second foundation principle, just to value our people and to take care of them. And then the third one is to safely improve every day. On our sustainability journey, that's where we see sustainability fitting into our company, to continuously improve every day. You know, the shortline world is a little bit different. You know, back to kind of one of Teresa's slides, you know, we haul about a third of the freight and we make about 5% of the revenue. So the business model is a little bit different than some of the larger railroads. And we're trying to figure out a way to have a sustainability portfolio within that kind of economic situation that we exist in. So I'm going to talk about a couple things that we're working on and then where we might go in the future. The first is just reducing the amount of time that a locomotive idles. We know that 85% of our emissions, or at least our greenhouse gas emissions, probably more of our criteria emissions, come from burning diesel fuel in our locomotives. And one way that we can have a pretty dramatic effect on both our fuel consumption and the resulting emissions is to simply idle less. There are a lot of reasons that locomotives idle, from keeping the brakes running to keeping the cab, you know, comfortable for the crew. But in many cases, particularly across our northern tier, they're idling to keep the engine warm so that the diesel doesn't, you know, gel up and render freeze the water, dump the water on the ground and render the locomotive unusable. So just to keep the locomotive fit for service. And there are a couple different technologies that we can use to keep them warm. The APU in that second bullet is an auxiliary power unit, which is what you see a picture of over to the right. It's kind of just a really small little engine that allows the large engine to shut off, but keeps things warm so they don't freeze up. There's a similar product, the DWS, is a diesel warming system. And both of those together can reduce idling significantly due to weather-related events. And then also many locomotives that are on the newer side for our fleet have an automatic engine stop start, or AESS, on them as well. We've been working with the American Lung Association, among others, in partnership to apply for Diesel Emission Reduction Act funding to add more of these systems on our fleet. We were awarded a grant with ALA to install 23 in 2021, and then 29 back in 2024. And those are kind of on top of other efforts that we have going, so that about 50% of our fleet has idle reduction technology in place, and we prioritize where it will be the most beneficial and where we're emitting the most for those projects. A second kind of, you know, more fun whiz-bang project is battery electric switchers. You know, Teresa and Mike have talked about some of the pros and cons that goes into various alternative technologies. You know, for us, working with some money from the state of Texas and a technology partner that we use on our locomotive control systems, we built and deployed 2 battery electric locomotives in Houston, Texas, at our large terminal there along the Houston Ship Channel. They've been in service for almost 2 years now. And we really like them. You know, one of the nice things about batteries is you can kind of customize the amount of power you're putting into things. So they're built specifically for an environment where all they're doing is kind of moving cars around or providing switching service. They're not going to go out on the main line. They're not going to be gone overnight. You know, they work during the day. They go to their base at night. They charge overnight. So we're able to take advantage of some of the conventionally existing technology without having to kind of invent a new wheel. All that said, you know, converting a battery to electric power is a pretty significant undertaking. You know, we would not be able to do it without grant funding, and we are very much still in the kind of testing and piloting phase. We've learned as we've gone. We have those 2 there in Houston. Fortunately, we are seeing a pretty significant reduction in the amount of maintenance that goes into them, about a 30% less or 30% reduction in the amount of maintenance time and inspection time that goes into those units. Of course, the fuel savings, you know, using a lot less electricity than we would have been using diesel, saving money that way. But then also the crew really likes them because they're quiet, because the acceleration and the power are instant and you're able to control things a little more precisely. So building off the success of that, we have applied for a couple different federal grants. The CRISI program is a Federal Railroad Administration grant program that shortline railroads are directly eligible to apply for. So we've applied for 2 different grants ourselves as Watco to repower 8 units each in each of those grants. And then we're part of a similar grant award that the state of California got, also a CRISI grant, to repower our 4 locomotives in the state of California. And so those locomotives will be deployed in the states you see there over the next few years. You know, when you get a federal grant, everyone gets very excited, and then you have to go about the process of actually implementing that, getting it to obligation and doing that. So it is very slow going, but we're pretty excited to be able to convert 20 or so more and to deploy them at switching sites. You know, a note, you'll see those locomotives have 4 axles on them, right? And you probably have never thought about the number of axles on a locomotive, but especially at customer facilities and in a number of our railroads, just the curvature of the track or the width of the opening that we're going through will only allow for a 4-axle locomotive. And you can't really buy a new 4-axle locomotive. So for us, this is also part of extending the life of that 4-axle fleet that is the backbone of our system. So we're pretty big on this project. We have a lot riding on it. We're very excited about it. But we do still have a long way to go to see if this is a viable solution for switching service across the country. And then perhaps a little less sexy, but this gives you a little bit of an indication on where to next. You know, I just kind of a few random graphics here, but the top 2 are kind of our utility consumption. You know, looking at that map of our network and then talking about how we're a much kind of smaller scale organization than maybe BNSF, the wrapping our head around our emissions is not an insignificant challenge. And so we've done some pretty significant data upgrades. You see, though, you know, we have over 4,200 electrical meters within our properties, nearly 3,000 accounts, you know, with 100 and some locations and 300 or so vendors. So just figuring out exactly what we're, and the chart below is our fuel consumption year over year from 21 on. And so we've done a lot of data collection. We've done a lot of integrating. You know, a lot of our railroads used to be kind of standalone businesses. So just trying to integrate them into one system so we can wrap our heads around what we're spending and what we're burning and how much electricity we're consuming and natural gas we're consuming has been a pretty big project for us that we're still working on. But in terms of where we're going next, you know, where will we deploy battery technology? Where can we reduce idling more? You know, where can we just use less electricity at some of our sites or less natural gas at some of our sites? It's going to be kind of that unglamorous but very important data crunching that's going to allow us to decide how we can best reduce our emissions going forward.
Thanks, Curtis. On to William at Wabtec.
Thank you. All right, can you all see my screen?
Yes.
Okay, Hi, I'm Will Carney. I'm Senior Product Manager here at Wabtec Corporation. I'm in charge of new engine technologies on our existing internal combustion engines as well as new and hydrogen fuel cell developments for powering locomotives. I also support our marine and stationary businesses that are adjacent to our locomotive businesses. For those of you who aren't familiar with Wabtec, so Wabtec is a company that's really three companies put together: Favorly, Westinghouse Air Brake Technology, and GE Transportation, kind of all smashed together. And then there's a lot of other companies that exist under the Wabtec umbrella. I believe over 65 right now, but between these companies, we've been working in rail for over 150 years now. Um, we have two main segments, the freight segment, which consists of equipment, services, components, and digital electronics, and then a transit segment. And I'll start with the transit segment first. But the transit segment, if you look across the world, in more than 90% of all transit systems exists a Wabtec component or components. So pretty much in transit, we're almost everywhere you can be. And then on the freight equipment side, if you look at the world's freight, 20% of the world's freight that's on rail is moved by a Wabtec locomotive. On a services side, we actively monitor existing assets that are out in the field. And every single day, there's over 8 million messages from locomotives on their performance or their health that come in and are monitored to really keep up the uptime of a locomotive, make sure they're operating clean, make sure they're operating properly, and helps their customers optimize their operations as well. On a component side, if we look at freight cars, so this would be the trailing tonnage of the locomotive in the freight cars. 20% of them across the globe have Wabtec components on them. And then we support all of these with digital services. And those digital services do a lot to reduce fuel consumption, emissions, and improve operations for our customers. And just one of them, our trip optimizer, saves over 500 million gallons of diesel fuel a year, which equates to about 500,000 tons of carbon every year. Now, going forward and where we're at today, there's a lot of technology that's on the table. The previous presenters have talked about it, about various technologies, but they really hit all sorts of different fronts. Starting at the top here with the internal combustion engine, we bucket it into about 4 main buckets. The first one being a Tier 4 engine. So we have a Tier 4 locomotive that's been introduced, first started field testing around 2013. It's remained relatively similar to that. There's been improvements in some digital assets, but generally speaking, it's very similar to how it was first introduced. However, there's another generation of it where we're adding energy recovery devices to these new assets, as well as making it available to existing assets. And those energy recovery devices are things like e-turbochargers, where we're extracting energy out of the turbocharger that we would normally just send as heat out the exhaust of the engine. We're recovering that and sending it to the traction motors instead of wasting it. Similarly, on the modernization front, we've heard where if you extend the life of the asset or repower an existing asset to obtain better fuel economy, reduce greenhouse gas emissions, you can increase tractive effort, meaning you could potentially reduce the number of locomotives that you need to run operations. All those things kind of fall under a modernization category. Those are like DC to DC modernizations, upgrading fuel systems on existing FDL-based engines through the addition of common rail. And then similarly to how a Tier 4 can have a E-turbo machine on it, you can have evolution engines, which would be Tier 2, Tier 3 type engines, have an E-turbo machine to save fuel as well and reduce carbon emissions. All those are compatible with biofuels, right? Renewable diesel, biodiesel. These you start stacking on top of each other. So, it's the same technology to recover the energy, but you use a lower carbon fuel as well. And now you have an even further drop in carbon emissions. And then we have next fuel. So we've talked about hydrogen a little bit, about hydrogen fuel cell locomotives. In some of the previous conversations, we talked about the infrastructure. There really isn't a great infrastructure for any fuel other than diesel. There's a big gap on the battery electric side. But if we want to go to another fuel, how can we do that? Well, we can use the same internal combustion engine that we have today, make some changes to it, and add a secondary fuel like a hydrogen, an ethanol, or a methanol. And what it allows you to do is start down that path of building out the infrastructure for a different fuel, for a hydrogen or an ethanol, reduce your carbon emissions as you're building that out, but you always have the backup of being 100% capable on diesel. So when you go back to 100% diesel, when you don't have that infrastructure available and you're still building it out, it's okay, right? You're not going to impact your operations. I think this is a great way that you can build out an infrastructure so you can do a wholesale changeover to a different fuel. And of course, we work on battery electric locomotives. Mike shared some images there of the demonstration unit that we worked with BNSF on. Currently, we are delivering what we call Flex Drive 2.0 and a Flex switch. This would be some lower power, like switching type locomotive applications, as well as some line haul battery electric locomotives for like the mining industry. And then down the road, you get to like a Flex Drive 3.0 that would have a additional capacity on it, different battery technologies or more advanced battery technologies, and the ability to do like a moving charge or almost like an overhead catenary as well. So that again, you can maybe not have to electrify an entire rail line, but do it discontinuously and do it where it makes sense, where it's cost effective and really helps your operations. And then the last piece is digital solutions, right? So these are trip optimizer, locotrol, smart HPT, PTC, pacing. All these things help to reduce fuel savings by either making the locomotive run at a more efficient state, or by improving operations for the railroads and having them less downtime, wait time, minimizing the amount of fuel or energy that it takes to get from point A to point B on the rail lines. Now, we have all these tools available. One thing that I do want to touch on is, as an industry, we kind of need some updated standards to help support the adoption of some of the technology. A lot of the current rail standards, test procedures, don't account for all new technologies, or sometimes don't foster new technologies. And what I mean by that is that there isn't standardized ways to measure some of these fuel economy improvements, these emissions improvements. There isn't a regulation that really helps or I'll say provides incentive to do a lot of battery electric locomotives or hybrid locomotives or or some other new technologies that are out there. They're very focused around, a diesel locomotive or an electric locomotive, or just a diesel locomotive like we had in the past. And I think what it does is slows us down a little bit, and that a lot of our discussions or evaluations of technology have to go back to a very customer by customer basis, which we'll do anyway. But I think as an industry, we can get a little bit more efficient and develop technologies a little faster if there's regulation and standards that support where we're going here in the future. And that's all I had, and I believe I pass it off to Andrew now.
Yes, thanks, Will.
Anytime.
Right. I'm Andrew Oquiga with UPS. I lead our policy advocacy on trucking, rail, and maritime issues here in our Washington, D.C. office. UPS is the biggest intermodal rail customer in the country, and by some measures, we're likely the largest rail customer in the country overall. So I appreciate GoRail inviting me today to share our experience as a rail customer and talk about how rail supports our sustainability goals. Let me start by talking a little bit about our UPS sustainability goals. We have 5 overarching environmental goals that are all funnel up to becoming carbon neutral by 2050. The first goal there is a 40% alternative fuel use in our ground operations by 2025. I'm proud to say that last year we topped 30% alternative fuel use in our trucking fleet, and we're now working hard to try and meet that 40% goal by the end of this year. For today's conversation, probably the most relevant of these goals is that bottom middle one, a 50% reduction in CO2 per package delivered by 2035. That's coming off a 2020 baseline. That includes our scope 1, our scope 2, and our scope 3 emissions. So as Teresa mentioned earlier, the scope 1 emissions for the railroads are our scope 3 emissions when we put our packages on one of your trains. And so we benefit from the lower greenhouse gas emission footprint that rail has as compared to other modes every time we put a package on a train, which we do tens of millions of times a year. We have been using rail providers for well over 50 years at UPS. We operate on 7 different railroads in North America. Our volume moves in and out of 80 intermodal terminals across the United States. And we move volume on about 500 or more than 500 trains across the US in a normal week. Our partnership with the railroads is really substantial and impressive. The UPS loads on trains occupy about 32 miles of train length during a normal day. That ramps up quite a bit during our peak holiday season. So we use more than 700 trains during those peak season weeks. And that equates to about 47 miles of trains during a day during the peak season. And what we get from that in terms of sustainability is a really big benefit. So on average, freight railroads can move 1 ton of our UPS freight almost 500 miles on a single gallon of diesel fuel. Over the past decade, we've avoided millions of metric tons of greenhouse gas emissions through our partnership. It's probably about 10 million over the past decade. And so it makes a really substantial difference in our overall emissions footprint and helps us get closer to meeting those goals that I had on the last slide. So wherever we can use it, freight rail, it's incredibly sustainable. And whenever we can meet our customer delivery promise with rail, we're always happy to use it. At the end of the day, putting customer packages on a truck is generally the fastest way to get it from point A to point B. And we still, of course, have to use a truck for the first mile to get it to the origin terminal, and use it at the last mile to get it from the destination rail terminal to our customer. But there are still lots and lots of situations where we can use rail and meet our customer promise. One big use case where our rail partnerships shine is packages that are with us over the weekend. So we run rail more heavily on weekends because we have a few extra days in transit. Getting a package on a Monday and delivering it on a Wednesday is harder if we give it to our rail partners. But if we get a package on a Thursday and we need to deliver it on a Monday, since we don't deliver it on Sundays and have that package for an extra day, we put as much of that volume on the rail as we can. And it's a really good solution, reduces our emissions, reduces our cost, allows us to meet our customer promise. And the better that service is with our rail partners, the more we're able to shift from other modes to rail, which we really like to do. We also use rail heavily during our peak season, and that's where we find the service to be the best. And we work really closely with all of our 7 rail partners for really good service over the peak season. We rely on the rail network to move our volume surge during December, and it helps free up our UPS drivers to move up higher velocity loads, and we're able to ramp up our use of the railroads during that season. I'd be remiss if I didn't talk a little bit about what we're doing, kind of the extensive work we're doing to move some of our ground fleet to alternative fuels. You heard earlier about renewable diesel and some of those other alternative fuels that our rail partners are using, and we've got common ground with them in trying to create and increase the market for some of these alternative biofuels that can work and that are more mature than battery electric solutions. And so our sustainability teams will meet from time to time and collaborate. And often we're trying to do similar things in terms of trying to figure out how we can, at a price point that is affordable and competitive, obtain some of those biofuels that can both power trucks and power our rail partners. That's it, and happy to take questions. Thanks.
Thanks, Andrew. Thanks, everyone. So now we have a few minutes, 10 minutes or so for questions. I see some folks use the chat, and that's fine. Either the Q&A or chat, type them in there. And let's see, Curtis and Mike already answered a couple questions. We could reiterate those.
Or Betsy, I've got one that I'd like to put to the group. So freight rail is already the most fuel efficient way to move goods over land and steadily improving. I'm wondering, in the current regulatory and policy environment, are we seeing initiatives that would be helpful in that regard, or even potentially going the other way and hindering maximizing progress toward greater sustainability? Anything?
Well, that's a tricky one, Ross. I think we're all very aware of dramatic changes in regulatory environments between administrations, between different appointees, just changes. And wherever you fall on the spectrum of what should be, when there are dramatic changes one way or the other, it becomes hard to plan for the deployment of technology. It becomes hard to plan what your capital needs will look like for the deployment of that technology. And it becomes difficult to factor in what the approval process will be for technology. We have good relationships with all of our regulators, and they all want to be helpful. And I think there's been a whole lot of dialogue in recent months about things we might want to see differently, or processes that we think could help accelerate deployment of things or allow us to collect more data. And we're seeing responses to that But I guess the one point I would just make is, hey, consistency, right? Even if something is different than way we'd write it, consistently, so that we can plan and we know how to deploy and we know how to move forward, and what goals we're kind of supposed to hit from a regulatory perspective is key to that.
Thanks, Curtis.
Anyone else on that topic? Okay, I'll just throw out one of the questions. Mike, you already answered this, but from Carla, just could you repeat or translate the length of testing time to implementation time into months or years? Seems like in some cases the technology may outpace testing and implementation times.
Yeah, and actually, I'll piggyback on what Curtis just said. We would advocate for a regulatory framework that I would call politically enduring, right? Regardless of who or which party would be in the office, because when we purchase locomotives, that's a 40 to 50 year investment, right? And we need to have the certainty that we'll be able to operate that locomotive over the course of its lifetime. With respect to technology outpacing it, that is another element that we have to consider when you're purchasing a brand new locomotive. I use the example, California is a great place to do testing because there's a tremendous amount of grant funding available. But we are advocating for some of the ways that these programs are shaped and really how the funds are dispersed, because you might end up in a situation where it's the equivalent of saying, hey, I will give you a free iPhone 2 if you promise to use it for the next 10 years, right? Nobody's going to take that deal. The influx of money is fantastic, but operational commitments that would see us having to test the technology for a considerable amount of time, long after the technology is obsolete, does create a challenge. So we're targeting short-term grants with considerable match that have the sole function of testing and evaluating the technology so that we can keep up with the pace of technology evolution.
Thanks,
Mike, I like the way that you worded it as regulation that endures across parties, because from an OEM perspective, the uncertainty that Curtis or Mike may have as a consumer of our products and the regulation, if a certain technology goes in and out of favor every 4 years, our development cycle, our validation cycle for something that burns this amount of fuel to do endurance testing and things like that, it's quite costly, right? And if that technology goes out of favor right as you're releasing it, then it causes some hesitation on the OEM side, right, to go develop that new technology, knowing that those risks are that no one will adopt it.
Great, thank you. So we just got a new question. What is the status of incentives by the current administration and the FRA, such as regulations and funding research and tech? I guess regarding regulations and funding research and technology implementation.
I think we're working through it. We've been the recipient or the beneficiary of 3 different CRISI grants. None of them are to the place where we've signed the contract to start the grant, right? And so I think, as whenever an administration changes, there's a certain period of time where, we don't yet have a new FRA administrator confirmed yet, though there are some high-ranking policy folks in place. And so there's always a little bit of change, right? They want to change the terms of the contract. That's normal, that's expected. I think something that's a little different this time around is that kind of all grants and contracts were paused for 90 days to do a big review of them all. And that 90 days has kind of passed. And so things that are kind of simple projects or very traditional rail projects, like just replacing rail or helping with ties for short lines, those are starting to clear. The logjam is clearing. Things are starting to move forward. For things that are more complex or more novel, everything is kind of still under review. And so I think, the status is a little bit TBD. There's a big tax bill going in town. There's all sorts of approach things that will still happen. And so we're going through that. We may be in June, but we're still kind of in that new administration, new Congress transition period where we have to see where things go. I think we've seen some nice, at the personnel level, some nice movement on how people will interact, how testing will be looked at by this administration. But in terms of incentives, I think there's a lot still kind of up in the air as we move through that. I will point out, kind of connecting that back to what Mike was talking about a minute ago, when the class 1 railroads are buying a locomotive, right, this is like a 50-year purchase, right? It's really expensive. It's going to run a really long time. And then when they're done with it, then the short lines buy it, right? Like we buy used, and we're happy to buy used, right? It's steel that's already manufactured, right? So it doesn't have to be scrapped. We can do it to extend the life of it. So it just underscores the longevity of this purchase and the importance of getting it right and the importance of doing the testing. Everything that we're doing for the business benefits of it, right? And that's part of kind of making the case to the FRA. When you see changes between administrations and maybe one administration really wants to focus on greenhouse gases and the other wants to focus more on, just kind of criteria pollutants or, things that come with diesel. When you see things like that, it's important for us all to embrace our role as, as good stewards and be as clean as we possibly can be. But we also have to go forward and make sure we're making things that make sense for our business. And so with the change in administration, one of the things we've all been doing is going in and making the case that, these battery electric locomotives, and we're building something that is very different, right, than what BNSF tested. It's a much smaller scale thing, but these are things that we made the business case for, just to make sure we stay on the good side of all of our regulators and don't get too out over our skis in case something were to change again.
Well, I think on that note, that might be a good place to stop. Any final thoughts? Seeing none, I thank you all so much for the great discussion. And yeah, take care, everyone. Thank you.
Thank you all so much.
Thank you.
Thank you very much.
Bye.